This is a good example, and I think you'll find it helpful. So you have tangent inverse on the top and 1 plus x squared on the bottom. You can't solve this integral instantly without any strategies. So I would say we need to use the u substitution, but the question is, what do you want to replace with u? Now when I look at this, the whole fraction, the whole expression, I notice on the bottom I have 1 plus x squared, and you know what, right away I think of the tangent inverse of prime formula. The derivative of tangent inverse equals to 1 over 1 plus x squared. Hopefully you remember that. So that tells me that I can actually replace tangent inverse of x with u. But let me show you exactly what I mean. So I don't want to skip any steps. So 1 over 1 plus x squared. I'm going to put it separately. Times tangent inverse of x dx. So I said this guy can be replaced with u, because I can find a derivative of this easily, which equals to that. So, and then after that I can solve my integral quickly. So let's see. A tangent inverse of x equals to u. Therefore, du equals 1 over 1 plus x squared dx. And that means we get, I'm not going to put my boundaries yet, u, that's my tangent inverse. And then I replace 1 over 1 plus x squared, this expression, with du. Because 1 over 1 plus x squared and dx, that gives you du right here. So you get integral of u du, which you can solve in seconds. It's u squared over 2, which means now let's go back to our tangent inverse. What was our u? Tangent inverse, but it's squared. So you get tangent inverse of x squared over 2. Now we can use our boundaries, 0 to 1. And you can solve it quickly. I can stop here. Actually, I want to solve it. 1. So that will be 1 right here. But the whole thing is squared over 2. Now, you can put minus and then plug in 0, but why do you want to waste your time? Because you know that tangent inverse of 0 is 0. So every minute, even second, matters. So skip it. It's not a free response. You don't want to show your work. So let's continue. I can put 0 here so that you know what I mean. Tangent inverse of 1 equals 45 degrees. That would be pi over 4. Then you have to square it over 2. Therefore, you get pi squared over 16, but you divide by 2, that would be 32. So this is my first example. Now let's do the second problem that I wanted to show you. I think we did something similar maybe a month ago, but I still want to do it again. Integral 1 of 1 over the square root of 4 minus x squared dx. You're probably thinking, the u substitution. Yeah, but what do you want to replace with u? X squared? How's it going to help you? 4 minus x squared, okay, equals to u. To find the derivative, you get negative 2x. How's it going to help you? So you get stuck. Now I'm trying to find some other strategies, but you know what? I notice actually I have 1 over the square root of a number minus x squared. And I remember that there is a formula, a sine inverse of x prime actually equals 1 over the square root of 1 minus x squared. Looks kind of the same, it's just I have this little 4 right here, and if I didn't have it, that would be easy. Now I can't erase it and forget about it, so I need to do something to this 4 so that I can use the sign inverse idea. What you can do, and that's the only thing I think you should do in this case, just factor it out. See this 4? Just pull it out. You don't want it. So let's see what we have. After you factor out the 4, you get 1 minus, and obviously x squared over 4, but I don't want to do that. I'm just going to put 1/4 x squared, and you'll see why I did that. Now, this 4, actually the square root of 4 becomes a square root of 2, so I'm going to put 1/2. You can pull it out if you want and put 1/2 and then an integral, but I'll keep it inside, and then I get 1 over and the square root of 1 minus. Now I'm still thinking about this. See this x squared? 1 minus x squared, so something squared, but I have 1/4 next to x, so then why don't you express this as 1/2 x, the whole thing squared. Now see right here, you have 1/2 x squared, but what do you have? The whole thing, what expression do you see in your square root? It's 1 minus 1/2 x squared. So it's kind of resembles that. So now I'm thinking of a u substitution. I actually want to replace 1/2 x with u, so that I can use 1 over the square root of 1 minus u squared expression, because I can take the integral of that and get sign inverse. So here's what I need. If you replace 1/2 x with u and then find the derivative of u, you get 1/2 dx. Oh, by the way, here, I forgot dx. And if you combine this 1/2 with this dx, you get du. You can actually solve this integral easily. Look what you get. You just get 1 over the square root, 1 minus, and 1/2 x you replace with u, so that would be u squared. Now 1/2 dx, it gives you du right here. So the derivative of what equals 1 over the square root of 1 minus u squared? Sine inverse. So you're going to say the answer here is sine inverse of u plus c. Don't forget the cupcake. We're almost done. Therefore, your answer is sine inverse of 1/2 x and plus c. If you want to check, you can find the derivative of this, use the chain rule, and you'll see you'll get the same thing we started with.